Hi, in this lecture I want to talk about three different activation functions. So in the previous lectures we discussed the sigmoid function. In this lecture let's introduce the tanh. So the tanh looks like this. Nice one here. 1 and A equal tanh of Z. So in this case here. I'm just writing out the equation in my amazing handwriting. So it's just the e to the power of z minus e to the power of minus c, e to the power of z plus e to the minus z. If you remember, the sigmoid function actually looked like something like this. This was 0.5, while a tanh function looks this way. A sigmoid function is usually used for binary classification, while a tanh is better than a sigmoid in some ways, as it's faster since the derivatives don't take as much as long to calculate. So what's the point of activation functions over the linear function? So if you remember, the activation function comes after the linear function, and the whole idea is whether we decide to fire up the neuron or not, if we decide to pass on some values to the next neuron. But mathematically, if we don't add the activation functions, then basically we're going to have a linear function. It doesn't matter how many hidden layers we have. We can mathematically prove then the input just becomes a linear function, a product of a linear function. So this was tanh. Now let's look at the ReLU. So more apparent in the literature at least. So a ReLU looks like this, where A max will always be. So the derivative of this will always be 1. So the derivative here is always the same, while if the value is underneath here, then the derivative will be 0. So, and there is a modified form called the leaky ReLU, which looks like that. And basically, if the value is less than 0, then the derivative will be much, much, much less. Yeah, so I just wanted to talk about these different activation functions. So I just wanted to talk about these different activation functions, which generally, if we, in the previous video, we did this, we presented this here, square brackets, sorry, so the activation function. And basically you can either have a tanh, a ReLU, a leaky ReLU, or a sigmoid here, which controls what will the value of the activation function be from the linear function. So what value, if we were to draw it that way, so let's say you're in hidden layer 1, this is hidden layer 2, so what is the value that's gonna go from here to the next neuron in the next layer? Thank you for watching. If you have any questions, please post them below.